Hello, hi, how's it going? Just a quick recap. In the last video, we were creating an instance and we got to the point down here where we were creating the instance and we had nothing for our layers. So again, Vulkan is designed to be as thin as possible, which means no error logging or state keeping or any of that stuff, no bookkeeping. So the purpose of layers is we can use them for debugging, and they insert themselves on function calls. They run validation to check that the API is being used in a valid way, and they can do a bunch of like checks and things. So let's get that set up. The first thing we'll do is we've got a vector of strings for the extension names that we're going to ask for. We'll also make a vector of strings for the layer names that we're going to ask for. And if we ask for nothing, then that's okay. This code will still work. But if we ask for something, then it will get passed through. So it's probably not a bad idea to make a function to check that our extensions and layers that we've requested are in fact supported. We can do that up above. So we can go up here. We're still in the same namespace. And we'll just make this function. So what it does is it takes these lists of names and yeah, just checks whether it's supported. So I'll just go down below. So we've set everything up. Now we'll go if that doesn't work, then there's no point creating the instance. And if we've got debug mode on, then we'll print those errors out in the supported function. Okay, to start with, we'll just print out all of the, we'll search our device and say which extensions will you support and print that out. So we're using this function here, enumerate extension properties, which we don't need to pass anything in. We can if we want. But yeah, we've got the dispatch is set there automatically. Layer names, we don't need to pass anything. Okay, so if we run this right now, then we get the list of extensions which it will support. As we can see, for instance, Win32 Surface and Surface are supported, so that's awesome. That's going to work. Okay, so then the simplest way to check if this works is we can just do a simple sort of quadratic search. That's fine. So we go through each extension and we haven't found it yet. Then we loop through until we find an extension which matches. And then we say, yeah, we supported it. And yeah, if we can't find it, then it's not supported. So this supported extensions is a vector of extension properties, and an extension property has an extension name and a specification version. So we're using the extension name to pattern match. Yes, and string comp takes two C style strings, so character pointers, and returns 0 if they match on every character. Otherwise it does like an alphabetical search. So we run this right now, and yes, both of our extensions are supported. Okay, awesome. So now let's do the same thing, and we'll also check our layers. So then the first step is we just get all the layers that our device can support and just print those out. Cool. So these are all the kind of things that we can stick in between our, stick in between our function calls. And the one that we are after is, there we are, okay, the Chronos validation layer. So just paste that, and yes, we have layers, and then we go if we're in debug mode, request validation layers, and just check this. Okay, then we'll just go back. Okay, so we've printed out the list of layers which we can support. Then we'll do the same sort of quadratic search against our requested layer names. We do the same string comparison, and yeah, that's looking good. So we run that now. And yes, we can support validation layers. Awesome. So right now, if we, well, I guess right now we do in fact have validation layers, because we're requesting them here when we create the instance. Another thing we can do is we can set up our own error logging function. Okay, so by default, this will kind of print it out to the console, standard out. But we might want to do like extra formatting. We might want to do like error checks, so only pass through errors if they're, of a certain level. Okay, so I'm going to do one more thing here, which is we have the extensions, and then we're going to say, okay, if we're in debug mode, then we'll also request these extension debug utilities. Okay, so we're actually good for now. We're going to shift the rest of the code over to another section, but there's a few things I want to set up first. So we'll go back to our engine. We've got our instance. Another thing we need is a callback object. And we're going to make a function to create that. Now there's a bit of a, should I explain this now or explain it later? I'll explain it now. So there's an extra thing that we need. Traditionally, under the C API, we would do like a little function call, get procedure address, to load in the function to create or destroy the debug messenger. However, as of this HPPP wrapper, there's another approach which is a little easier. And what this is we create a dispatch loader object. All we need to do is, once we've created our instance, we pass that in, and the type of loading function that we want to use with that dispatcher, and then that creates an object. So later on, when we create something or do any work, we pass in that dynamic dispatcher, and that loads in the instance procedure address. Cool. So we're going to work with that. And So for that reason, we're going to have this one here. And this is, what is it? It's a okay, cool. So let's go ahead and create that. We can create that dispatch loader at any point after the creation of the instance. So let's go ahead and make that here. Okay, so we go ahead and create that based on our instance and this one here. Let's double check this, right? So dispatch loader takes a pointer function of this type, and then get instance procedure address is a pointer function of suitable type. Okay, cool. So that is set up. So then all we need to do is let's go. Okay, so what we're going to do is we're going to say debug messenger is, we're going to declare this in a second. In the namespace, we're going to go make, there's going to be a function called make debug messenger, and that's going to take the instance and that dispatch loader. Okay, cool. Hasn't been created yet, so let's go ahead and create it. So we're going to try to batch these based on functionality. So I'm going to call this logging, and now we can go ahead and do that. So we have of course we don't have Vulkan yet, so we'll just and of course it's not actually that, is it? It's not void, it's cool. All right, so it's kind of a few things here. For one thing, we need a function. We need a function to use as a callback. So I'm just going to paste this in. This is a pretty standard boilerplate. There's a lot to read here, a lot of it's documentation. So we have our debug callback function, that's what we call it. We take as one of our arguments, this is specified by the API, it has to be this. It takes a message severity flag, which you go back up above. There are different levels of severity. Verbose is like warning all, just being very explicit. And as we can see, these are bit masks. So we can, bit flags, we can like or and them together. Okay. Yeah, and then maximum level is just effing out everything. So it's future-proofing every single, if there's a new warning level defined, this will just cover all those bases. Cool. So then we have message type. So if we look up here at message type, we can have general info, validation info, performance if we're using the engine in an unoptimal way. That's fine. And then callback data. So callback data is info about the error which has occurred. So don't worry about this stuff. We have ID name, ID number. P message is the string contents of the error message, and all these things. These, yeah. We can adjust this as we need, but right now we'll just keep it really, really simple. So we just go validation layer, and then we print out the string representing the error message. Cool. And we print that out to the error console. Okay, awesome. So now we need to use it. Okay, so we go and make this create info. Now the create info, again, the first argument. Okay, so we have these flags, which are like optional settings that we can set when we create something. By default, they are 0. So if we click in here, we can see here, yeah, it just returns nothing. Yeah, completely empty. But if we wanted to set additional flags, we could set that. Okay, then we have the kind of severity and message types that we're going to take. So this is a HPP thing. Normally we would have the enumerators just like we have up above, but for C++, we declare this as an enum class, and that's basically this wrapper. It's basically what the E warning and all that is encapsulating. This makes it a little bit safer. Okay, yep, so we're taking any level of warning for any type of thing. This next bit is a pointer to our debug callback, and then the last bit is user data, a void pointer. So if we want to pass in any other information at the time, then we could specify that here. And that would be taken, that would be available to us in this variable, which I guess at the moment is null because we're not passing anything in. Cool, 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 cool. All right, so there we have it. We have created our messenger. And you know, as you know, code is in the description. So we'll just go to the engine, and hopefully this should go away. Of course, we need to import that, don't we? Cool. Okay, excellent. And okay, so we make the instance, then we'll make the debug messenger, and then we'll run it. Cool. Cool, cool, cool. So as we can see, it's working. We have a very useful error. The messenger has not been destroyed. Of course, no problem at all. So all this means is we need to go down to the cleanup function, and we'll go instance destroy messenger. And what does this take? We need to take a messenger, so we'll go put in our debug messenger. Allocator, so the reason I'm using null, the reason I am defining null pointer here, even though it's there, is it's a little, I'm a little suspicious because I want to get to that dispatch. I don't want to accidentally pass the dispatcher in as the allocator. That might be weird. So I'm just going to go make it very explicit, make it very clear. Now if we run this again, it works. It works. Awesome. Okay. Okay, so today what we did is we had a look at, first of all, just a little bit of type safety, just checking that a list of extensions and layers is supported, and seeing how to check which, check the full set of extensions and layers that our system can support. Then we had a look at how to request the validation layers and set that up in the instance. And then remember, simply having that set up doesn't guarantee or doesn't give us a full level of control over error logging. So we also had a look at how to create a callback function and create that, basically pass that in as our error logging function, and create and destroy it, as well as dynamic dispatches. So good. Okay, so I hope you had fun, and I'll see you in the next one. Bye.